Hi, my name is Caroline Culpepper, and this is my presentation for Laboratory 1. To start with the introduction, I wanted to begin by explaining a little bit about charge and the conservation of charge. So charge is conserved under all interactions, and so using the tape as an example in the diagram I have below, both tapes were initially neutral in charge, and upon their interaction, there was an electron transfer causing one of the tapes to become positively charged and the other piece of tape to become negatively charged. However, the net charge is still zero, so charge is conserved. The goal of this lab was to use quantitative and qualitative data to calculate the charge on a piece of tape. The major finding that I discovered was that tape is positively charged, and additionally, this lab gave me more information about the relationships of forces that act on an object. Some assumptions that we made throughout this lab were that each piece of tape has the same net charge, and that the charge on the tape is going to be considered as a central point charge. The hypothesis that I had for this experiment was that the tape is positively charged and the two pieces will repel each other, causing the levitation. I was able to infer this by the interaction with the tape and the pen. The tape was attracted to the pen because the tape was positively charged and the pen was negatively charged. Then I moved on to calculating the charge on the piece of tape by using the distance that I measured between the two tape strips while levitation was occurring. That distance then needed to be converted into units of meters. Following this, I calculated the gravitational force by using the standard measurement of 0.0002 kilograms for the weight of the tape, and then multiplied that by gravity, which gave me 0.002 newtons. Based on the assumption that the tape is not moving in its levitated state, gravitational force and the electric force will be equal. So then using the equation for the electric force that I have listed on this slide, Q was calculated as 8.24 times 10 to the negative 9 coulombs. To solve for the number of electrons, I divided this value by 1 times 10 to the negative 16 coulombs, or the charge of one electron. This gave me 8 times 10 to the 7 electrons. In GlowScript, I was able to use the digital platform to then create the same results. I began by establishing my constants. Then I created two spheres. I established another variable of distance. I calculated gravitational force by using the values of the established constants, so that if one of these values were to change, I would still be able to have an accurate answer. And then I calculated charge and instructed the program to print. The charge is 8.24 times 10 to the negative 9. For final questions, if electrons were positive, then the tape would have been negatively charged and would have repelled the pen and been attracted to positively charged objects. This would have no effect on neutral objects. It would still be attracted to neutral objects. And finally, it's important to handle the charged tapes as little as possible because interaction between the charged tape and your hand causes a charge transfer which would change the charge on the tape and invalidate the experimental results.